Hello and welcome to this lesson on advanced indoor air quality technologies and HVAC system design. So the content of this lesson is air purification technologies. We're going to talk about integrating indoor air quality technologies in HVAC design. We're going to talk about filtration methods, selection and challenges. And finally talk about energy efficiency and IAQ. So the learning objectives. So at the end of this lesson, you are going to learn about air purification technologies, such as UV light purifiers, ionizer, and activated carbon filters. Explore how IAQ technologies can be integrated into HVAC systems to optimize air quality, and learn how HVAC systems can maintain air quality while managing energy use. So let's start with a question. Think about a time when you've been in an environment with poor air quality, whether in a workplace, school, or a public building. How do you think advanced HVAC systems and air purification technologies could improve that space? So now that we have been discussing the sources of these bad odors or stuffy air, so we can think about ways that the HVAC system help us. No, we were discussing about integrating or increasing the amount of outdoor air that gets in, but we also should think about the energy. We can think about technologies for filtration, and we can think about different ways that HVAC systems and air purification can be integrated. So air purification technologies complement HVAC systems by targeting pollutants that are difficult to filter with traditional methods. When the UV light purifiers use ultraviolet rays to kill or deactivate bacteria, viruses, and mold, effectively reducing biological contaminants in the air. Ionizers work by changing airborne particles, making them easier to capture by filters. Activated carbon filters are effective for removing odor, gases, and VOCs from indoor air. Finally, we have ozone generators that can also be used to remove odors, but they should be used with caution as ozone can have harmful health effects when present in high concentrations. Integrating indoor air quality technologies in HVAC systems, so we can use techniques like zoning that allows the building to be divided into areas with different IAQ needs, enable customized controls for each zone. We can use a variable airflow control that help us adjust the amount of air based on the detected levels of pollutants, ensuring that the HVAC system responds dynamically to changes in indoor air quality. Air purifiers can be integrated into HVAC systems to continuously clean the air, and smart control equipped with indoor air quality sensors allow for real-time monitoring and system adjusting. To improve indoor air quality, HVAC systems rely on various filtration methods to capture and remove pollutants from the air. We have mechanical filters that are highly effective at removing particles such as dust, smoke, and allergens. Have electrostatic filters use electrical charges to capture airborne particles, while absorption filters, they often containing activated carbon, are used to remove gases and odors. When selecting a filter for indoor air quality, there are several factors to consider. Filter efficiency is crucial. How well the filter captures pollutants like particulate matter, the higher the efficiency, the better the filter performs. The dust holding capacity is another important factor. It refers to how much dust the filter can accumulate before it needs to be replaced. And we have airflow resistance, that is the pressure drop caused by the filter. It's important to choose a filter that doesn't reduce airflow too much, as this can impact the HVAC system's efficiency. One of the biggest challenges in filtration is managing the pressure drop, which occurs as air flows through the filter, as a high pressure drop can reduce the efficiency of the HVAC system, leading to increased energy consumption and higher operating costs. So regular maintenance is crucial. Filters need to be cleaned or replaced regularly to ensure that they continue to work efficiently. There's always a balance that to be struck between filter performance and operational costs. Choosing the right filter involves considering both efficiency and long-term cost effectiveness. So balancing energy efficiency with optimal indoor air quality is essential to avoid excessive energy cost while ensuring a healthy indoor environment. Energy efficient filters reduce the energy consumption of HVAC systems by minimizing pressure drops and maintaining proper airflow. Variable speed fans can adjust the airflow to match indoor air quality requirements, improving energy efficiency without sacrificing air quality. Then heat recovery units allow buildings to reuse the energy from exhaust air to improve indoor air quality while reducing heating and cooling costs. So we have some key takeaways for this lesson. Indoor air quality technologies are essential from clean air. So UV light purifiers, ionizer, and activating carbon plays a role in improving air quality. HVAC systems must be smart and dynamic. Integration of indoor air quality technology, zoning, and variable airflow controls ensures effective and efficient air quality management. Then balancing indoor air quality and energy efficiency. It's possible to maintain indoor air quality while optimizing energy consumption with a smart HVAC system design. Finally, I invite you to continue learning in this topic so you can explore the role of Internet of Things, devices, and smart building systems in monitoring and optimizing indoor air quality in real time. Dive into factors like lighting, lighting acoustics, and thermal comfort contribute to the overall indoor environment and how they interact with indoor air quality. Then investigate the long-term health effect consequence of poor indoor air quality, such as cardiovascular and respiratory diseases, and how improving indoor air quality can prevent these issues. Thank you for listening to this lesson.